The heart is a muscular pump that moves nourishing blood through our bodies. The heart also requires nourishing blood and has its own circulation that ensures blood supply. The heart receives its blood supply from arteries called coronary arteries. The word coronary comes from the same root as coronation. These arteries sit on the top of the heart muscle like a crown and send hundreds of smaller branches deep into the heart tissue. We have two coronary arteries that originate at the base of the aorta, the giant artery that carries blood rich in oxygen to the rest of the body. This illustration shows the left and right coronary arteries. The left coronary artery is roughly twice as large as the right coronary and feeds 2/3 of the heart muscle. The left anterior descending artery, or LAD, which feeds the front wall of the heart, and the circumflex artery, which feeds the side wall of the heart. The right coronary artery feeds the bottom wall of the heart. A blockage, or plaque, typically forms near the beginning of an artery before its multiple branches enter the actual heart muscle. We will next take a closer look inside a coronary artery. The coronary artery is a living muscular tube that carries oxygen-rich blood to the heart muscle. A close look shows that the coronary artery has multiple circular layers, like an onion. The innermost layer is called the intima. This layer has a delicate cell lining known as the endothelium, which is in constant contact with blood flowing through the artery. The intima is encircled by a layer of muscle called the media. This layer can squeeze and narrow the artery or relax and dilate the artery. Exercise or nitroglycerin tablets cause the media to relax and dilate the coronary artery, such that the heart muscle receives more blood. The outermost layer is called the adventitia. This layer protects and nourishes the inner layers of this living blood vessel. Atherosclerosis refers to the process of plaque formation within an artery. We now believe that plaque begins to form upon the intima when the delicate intimal lining is injured or inflamed. This injury may be caused from the pulsating, shearing force of high blood pressure or high levels of lipids or fats in the blood, or a number of other factors. Plaque tissue forms as a response to this injury, much like an oyster forms a pearl because it is irritated by a grain of sand. Circulating white blood cells, known as monocytes, attach to the injured intimal cells. The monocytes migrate under the surface of the intima and stimulate the underlying smooth muscle cells of the media to multiply and grow. These cells become engorged with lipids. Lipids also may accumulate in the spaces between these muscle cells. At this early stage, we would refer to this cell collection as soft plaque. Later, the plaque forms a tough, fibrous cap. This plaque will become hardened with a bone-like material rich in calcium. We refer to this plaque as hard plaque. The slang phrase hardening of the arteries refers to this hard plaque. The plaque may bulge into the coronary artery and narrow the blood flow channel. The flow of blood within a coronary artery is not diminished until the blockage represents more than 70% of the artery diameter. With continued injury or inflammation, the lipid-laden cells on the interior of the plaque continue to multiply, grow, and bulge. The fibrous cap starts to thin and fray at its margins. Finally, the plaque ruptures, releasing fatty-rich cells and material into the channel of the coronary artery in contact with flowing blood. This oozing, fatty-rich material causes massive clotting, or thrombus formation, which completely stops up and obstructs the flow of blood within the coronary artery. A heart attack occurs when the blood flow down a coronary artery suddenly stops. We believe that an unstable plaque within an artery ruptures and causes massive clotting within the coronary artery so that all blood flow stops. The region of heart muscle fed by the clotted artery becomes starved for oxygen-rich blood and begins to die. Once the flow of blood down the artery has stopped, the downstream heart muscle becomes starved for oxygen-rich blood and soon becomes injured or dies. If blood flow is restored to the heart muscle within 1 hour, the damage to the heart is minimal. But damage to the heart muscle is complete and irreparable if blood flow is not restored within 12 hours. We call this permanent damage or death of heart muscle tissue a heart attack or myocardial infarction. It takes 4 to 12 hours for the damage to become permanent. Close attention to the early signs of heart attack and quick action in seeking help may limit the damage to the heart muscle. Once a heart attack is started, the more time that passes, the more extensive and complete the damage is. Cardiologists often say that time is muscle.